Okay, hello everybody, this is Miss Pi. I am doing the Unit 7 test review. I will hopefully be able to go through this pretty quickly. So let me go ahead and get started. This test is all going to be about your exponential properties and exponential functions. So in this case, we have x raised to the 5th power that is then raised to the 7th power. And this is a power raised to a power property, so you're going to multiply the 5 and the 7 together, and then 5 times 7 is just 35. So the answer would be x to the 35th power. Here you have a base number raised to the 8th power times the same base number raised to the 3rd power. So you're going to add the two exponents together, and then 8 plus 3 is just 11. So these two are fairly similar properties, situations. You just need to know that if it's a power raised to another power, you're multiplying. And if it's a base and an exponent times the same base and an exponent, you are adding the two exponents together. And yes, I know that in your calculator you can put 2 raised to the 11th power, but I believe on the test you're looking for 2 raised to the 11th power, not whatever big huge number that is. All right, so this situation we have is you're going to use your quotient identities, and I'm trying to remember if I have you adding those two. Yes. So in your numerator, you would add the 6 and the 9 together, and then you would just leave the denominator alone. And then in your numerator, 6 plus 9 gives you 15, and again, your denominator just 10 to the 5th power. And then when you have this situation, you can get rid of your fraction. If you have a base 10, if you have the same base numbers, here you would just subtract your exponents. So it would be 15 minus 5, and that is 10 to the 10th power. Okay. Another problem very similar to some we've already seen. You're just going to add the 4 and the 3 together, so that's y raised to the 7th power. When you have a situation where you have more than one thing in a set of parentheses and then that's squared, you've got to distribute your square to each term. So it'll be 7 squared, q squared, and p squared. And then if you have a number that's raised to some power like this, if it's a small power like 2 or 3, then go ahead and put that in your calculator or multiply or calculate it out. So 7 squared would be 49. And so like if it's a multiple choice question, you're not going to see 7 squared, but you would see 49. And then q and p are both squared separately. All right, now this one, w raised to the 0 power. Hopefully you remember that anything raised to the 0 power is just 1. So 3 times 1 is just going to give you 3. Okay, here's another one where we have a quotient, and remember that if you have a variable that does not have an exponent, then your exponent is 1. And with this one, let's go ahead and subtract the exponents from the denominator from the exponents in the numerator. And notice you have m is an m and then n and n. So the 12 and the 4 are going to be paired up, and the -5 and the 1 will be paired up. So you're not going to have like -5 and 4 because they have different base numbers. They have to have the same base number. All right, so you would have m raised to the -5 power minus 1, and then you would have n raised to the 12th power minus 4. And then go ahead and simplify that further. So you get m to the -6th power times n to the 8th power. However, your instructions will probably say something like, do not leave negative exponents. So if you have a base number or a variable raised to a negative exponent, you can make it to have a positive exponent by putting that whole thing in the denominator. So m to the -6th power, if I put in the denominator, it suddenly becomes +6. Okay. This one here, we have a quotient in our parentheses, and then that's raised to the negative fifth power. Go ahead and distribute everything first. And then with this being 2 raised to the negative fifth power, to make it positive, I'm going to move this to the denominator. And then, so we have 2 to the fifth power, positive fifth power in the denominator. And then because you're already in the denominator here, when you do t raised to the negative fifth power, to make it positive, you're going to move that up to the numerator. So that's positive. Now, if you don't find this as one of your answer choices, go ahead and plug in 2 to the fifth power in your calculator and see what you get, and you would get a 32. Okay, moving on, we have this one. We've got to distribute the 2 before we can take care of the m to the sixth power. So you would have negative 3 squared. Make sure if you plug that into the calculator that you put the negative 3 in parentheses. And then you would have m raised to the fifth power times 2, and that's because you have an exponent raised to the power of another exponent. So you're multiplying your 2 exponents together. And then at the end, you just have m to the sixth power. Let me see if I went ahead and distributed. Yeah. So the reason why you want negative 3 to be in parentheses is because negative 3 squared, or negative 3 times negative 3, would give you a positive 9. And then m to the fifth power times 2 is m to the 10th power. And then we have m to the sixth power left over. And then I think on this one, you're just combining the 10 and the 6 by adding them. And then your final answer is 9 times n to the m to the 16th power. Okay. Let's look at this one. Again, you have to distribute what's in parentheses. However, let me see. I think I took care of, yeah. So notice usually I would take care of the exponent first, but because I have so much weird stuff happening in the parentheses, I'm going to take care of that first. I'm going to make these exponents positive. So I will move the a down to the denominator to make it a positive raised to the third power, and b is going to go up to the numerator, and 2 is just staying the same. Okay, now that I have all that done, now I'm going to distribute the 4 throughout. So it'll be 2 times 4 because you have a power raised to another power, and then 2 here is raised to the fourth power, and then a to the third times 4. Okay, then you're going to just multiply everything out. You get b to the 8th power, 2 to the 4th power is 16, and then a to the 12th power here. All right, next problem situation. Again, we have another quotient. Let's take care of this negative that's inside the parentheses. So when you do that, you're going to end up with no denominator and y to the positive fourth power in the numerator. And then we're going to take care of the distributing the negative 3. And so we'll have 2 raised to the negative third power times x squared times negative 3. Notice that you still have to multiply, but now we're multiplying by negative 3. And then y to the fourth power times negative 3 as well. And then go ahead and multiply everything out. 2 times negative 3 gives you negative 6. 4 times negative 3 gives you negative 12. We're good there. And then pretty much because everything has a negative power, you're just going to be left with a 1 in the numerator. And everything else gets put in the denominator. Go ahead and calculate what 2 to the third power is, and that'll give you an 8. And then x to the 6th power and y to the 12th power are positive if we put them in the denominator. All right, let's look at this one. Let me see, I can't remember if I take care of the numerator first or the denominator. Okay, so I did both. All right, so we're going to do 2 things here. We're going to take care of this the negative 3 on your exponent for d by moving it up, and we're also going to distribute to the third power to this 4 and this c. Okay, so in your numerator you'd have 4 to the third power times c to the third power times d to the third power, and then the 8 and the c to the 8th power also are going to just stay down here. After that, you want to go ahead and calculate what 4 to the third power is, and you get 64. And notice I had c to the 8th power down here, but I also have a c to the third power here. So go ahead and combine those. So we'd have c raised to the third power minus 8 here. And then notice my denominator suddenly just disappeared. So the reason why that happened is because if you do 64 divided by 8, that gives you 8. Okay, and so we've gotten rid of our denominator completely, but now c to the third minus 8th power is going to be c to the negative 5th power, so that means that in the long run, we are going to end up with a denominator, but it's going to be c to the 5th power. All right, so that was several different practice problems just applying your exponential rules, your power of powers, your quotient rules, your product rules, all those fun stuff. All right, so now let's look at some application problems. So use the rectangle to answer the next two questions. So this side measurement, or my length here, is 2 times x to the 5th power, and my width is 3 times x to the 4th power. So the problem is that we want to write the simplified expression for the area of the rectangle. So if you remember, the area of the rectangle is length times width. Okay, and so you would just take your two side measurements and multiply them together. But then we need to simplify that as much as we can. So this 3 can be multiplied by 2 to give you 6. And then x to the 4th power times x to the 5th power, you would just end up adding your exponents. And then your simplified expression, or simplified area, would be 6 times x to the 9th power. Okay, now we still have the exact same rectangle, but this time instead of finding the area, we're going to look for the perimeter. And the formula to find your perimeter is 2 times your length plus 2 times your width. Okay, so let's go ahead and plug these values in. We're going to have 2 times 3 to the times x to the 4th, and 2 times 2 times x to the 5th. Those are just these measurements here and here. Go ahead and multiply everything out. So 2 times 3 gives you 6, and 2 times 2 gives you 4. Notice that we're adding here, and we are not doing anything else to this formula. We're not going to try to combine. This is not going to be 10 to the x to the 9th power or anything like that. You're just going to leave it just like this. You're done. Please do not try to combine those terms. In order to be able to add or subtract terms, you have to have the same variable, which we have the same variable, but you also have to have the same exponent. And here we have an exponent of 4, and here we have the exponent of 5. So you cannot combine that any further. All right. So this one, you have to create an exponential function for each table. So we have these table values, and we have to figure out what our formula is. So if you remember, your exponential formula is y equals a times b raised to the x power. And hopefully you remember that a tells you where your y-intercept is, and you're just looking for what your y value is at your y-intercept. Okay, and your y-intercept is when x is equal to 0. Okay, and then your b value is, hold on, let me move this. There we go. B value is your ratio or your rate, and to find your common ratio, I know I probably didn't use the phrase common ratio in class, but we've talked about either your rate of increase or your rate of decrease. Okay, so that's what you're going to do. When we have a table and we're looking for our common ratio or our rate, we need to find we need to take any two consecutive y values and divide the second y value by the first y value. So hopefully you remember that. Let's go ahead and look at this. So it's the table that I just had up here. Now, a is when x is 0. So here's our x value being 0, and whatever your y value is, that's your a value. So in this case, our y value is 3, so our a value is 3. Now, I need to take any two consecutive y values and divide them. I'm going to divide the second one by the first one. So this time I chose to do 75 divided by 15, but I could have also chosen 15 divided by 3, or 3 divided by 3 over 5, and etc. I could have done any of these two that were consecutive. I chose 75 over 15. If you plug that into your calculator, you get 5. If you do 15 over 3, you also get 5. So it's going to work either way. So I now know my a value and my b value, and so my equation would be y equals 3, which is my a value, times my b value, which is 5, raised to the x power. Okay, let's look at this again with a different table. This time, when our x value is 0, our y value is 7, so a is 7. And b, again, you could take any two consecutive terms. I'm doing the 7 and the 28. I'm not a big fan of fractions and fractions, so I'm avoiding these. So I did 28 and 7, and remember, it's when you're going from left to right, it's the second value divided by the first one. So it would be 7 divided by 28, which will end up giving me a fraction, so that'll be my rate would be 1/4. And it is fine to have a rate that's a decimal or a fraction. So my a value is 7, my b value is 1/4, raised to the x power. So hopefully you remember that when your b value is greater than 1, in this case this one, then you have an exponential growth. And when your b value is between 0 and 1, then you have an exponential decay. So this table would create an exponential decay. This table creates an exponential growth because of your b values. All right, so we now have our graphs. We have fill in the table, then graph each exponential function, then state if it's a growth or decay. All right, so we can do this in any order. In this case, this is our function here. Notice our a value is not showing up, so the a value is 1. So that tells me that when x is 0, my y value is going to be 1. I'll uncover that in a minute. And I'm going to pick, I believe in your review packet, I put these numbers down. So I'm just going to plug them into this equation and find my answers. If I plug them in using my calculator, if I have 3 raised to the negative third power, actually I think that's wrong. That should be 27, right? Let me plug that into my calculator. 3 raised to the third power is 27. Sorry, there was a typo there, guys. It's 1 over 27. And then 3 raised to the 1 power, or negative 1 power, is going to be 1 over 3. And then, or 1/3. And then, like I said earlier, because my a value is 1 here, then when x is 0, my y value is 1. When x is 1, I get a 3. And then here I get 27, when x is 2, I get a 9. So 3 squared is 9. If I did 3 to the third power, then I would have a 27 here. All right, so when I plot all those points at -3, I am going to be super, super close to the x-axis. Okay, remember this is where you plot your x values, and this is for your y values. So here I would be right here, and then 1/3, I would be a little bit further away from the grid line here. Sorry, when x is -1 would be right here. I'd be right here. When x is 0, I'm right here. When x is 1, I'm at 3. And then when x is 2, I'm at 9. And I just count up. So my graph will end up looking like this. Okay? If I remember correctly on the test, you'll probably have to sketch it on your paper, but then when you put your answers in the calculator, you'll have to pick the graph that matches the graph you drew. Okay, let's look at another one. Oh, sorry, I forgot. We need to state whether this is growth or decay. In this case, it is growth because my base number here is greater than 1. Okay, let's look at the next example. This time, my base number is 1/3, so it's going to be a decay because I am decreasing. And then when I plug these values in, I'm really hoping I didn't mess up this time. Oh, good, I didn't. Let me look at this. Oh, it's because I put a -3 here. I probably should have had a 2 there, and that would have given me a 9 here. So guys, on your problem, on your review, you can either leave it as a -3 and put 1/27 here, or change this to a -2 and put a 1/9 here. Because at -3, 1/27 is like, yeah, it's so close to the x-axis, it's ridiculous. All right, so let's look back to this one. Sorry for jumping around so much. Yeah, so I'm just plugging in -2, -1, 0, 1, and 2 in for my x values, and I'm plugging this straight into the calculator to find my answers. So 1/3 raised to the -2 power gives me 9. And then I get a 3, 1, 1/3, and 1/9. What's going to happen is I'm going to start way up high, and then I'm going to be decaying. I'm going to be going down, and it's going to flatline like this. And so my graph ends up looking like this. Okay. Sorry about the background noise. I have people coming in and out of my classroom. All right. And then the bell's going to ring pretty soon. I will try to get done with this really soon. All right, so we're almost done. For scientific notation, we are moving the decimal over to right here and then counting how many points you move it over. So 1, 2, 3, 4, 5, 6, 7 places. Because we're moving it to the right, it's 10 raised to the -7th power. Over here, we're going to be moving it to the left. And you want to move it in front of the first significant digit. So it'd be right here between the 6 and the 3. And that's 8 places, 1, 2, 3, 4, 5, 6, 7, 8. So there you go. Let me see how much more we have. Oh my gosh. All right. Let me try to finish this. Sorry if there's a whole bunch of noise. Let me just show you the answers for these. So with this one, we're writing each number in standard form. So because this is a -4, I'm going to move my decimal place over this way 4. So this is what we have. Because this time we have it to the 9th power, we're moving it to the left. If it's positive here, it goes to the left. And this is what we have. I do want to say with this one, make sure, give yourself some commas so you can keep track and make sure you have all the right zeros. With this one, simplifying each expression, write your answer in scientific notation. So 4 times 10 to this 2nd power and then squared. You've got to distribute that squared to both terms in the parentheses. So you have it like this. And then 4 squared is 16. And then 10 to the squared times 2 is 4. And then here, take care of this negative. Actually, you can divide the 20 by 5 first, and you end up with 4. And then move the 3 or 10 to the -3rd power down. You end up going ahead and adding those two in the denominator. You get 4 to the 10th power, or divided by 10 to the 10th power. And then you can, to write it in scientific notation, because you're down here, it would be 4 times 10 to the -10th. And then this last one is your bonus. I am just going to show you all the parts. And this is for this first section here. You're going to have it like this, then this, then this. And then for this part over here, let me uncover those sections. And then once you get to this point, you still have to you want to keep them separate. Go ahead and keep combining everything. And then now, because you're multiplying, oh my gosh, you can, let me see, what did we do? Oh, the c to the -10th power went ahead and went into the denominator. c to the negative third power over here went into the denominator, so we're like this. And then we can go ahead and multiply everything together, all together. And so we're going to have this, and then this is your final answer. So guys, all this, I know I didn't do very much explaining. It's all basic properties of exponents. And I believe this ends up being a bonus question. So it is worth quite a bit, but if it's too hard to figure out, then don't stress yourself. All right, I am done. See you after spring break.